All right, higher order derivatives and implicit differentiation. That's what our part 2 lesson here is going to be. Higher order derivatives, basically we just mean we're going to find the second derivative in implicitly defined equations. All right, so let's just get started. The instructions here are going to be to find the second derivative of y with respect to x of the following equation. 2x cubed minus 3y squared equals 8. Okay, so let's start with the first derivative. Can't get the second derivative without taking the first derivative. So first derivative will be 6x to the second power minus 6y to the 1 power times the derivative of y, which is dy dx. That's all equal to 0. Be careful. It's easy to forget to derive this constant out here. But you're deriving both sides, so you get 0 for the derivative. Okay. Now, we are going to get dy dx by itself. When you do that, you will end up with this. Dy dx is equal to negative 6x squared divided by negative 6y. Then, you will get negative 6 over negative 6 is just 1, so you get x squared over y. So that is your first derivative. Okay. Now, we're going to take the second derivative of that. And so let's see, what's a good way to organize this here? I guess we'll just do this. Should have left myself some more space to the right. Anyway, so we'll take the second derivative, and that is going to be just the derivative of this expression right here on the right. So the second derivative of y with respect to x is equal to, we have a quotient here, so we have to do the quotient rule. So we have the bottom times the derivative of the top minus the top times the derivative of the bottom. Derivative of y is dy dx. Very, very easy to just look at y and then just put 1, but you've got to remember that y is the dependent variable. We're assuming it's a dependent variable, and that the derivative of that is dy dx. All right, that's all divided by the bottom squared. Now, this is an okay answer. The problem is that it has this dy dx in it, okay? And we want our final answer to have x's and y's. So we just want the second derivative of y with respect to x in terms of x and y. So to fix that, I know what dy dx is. It is this expression right here. It is x squared over y. So I'm going to substitute that in for dy dx here. Okay? So let's do that. This is the second derivative of y with respect to x is equal to, we'll clean this up a little bit, 2xy minus, and then we'll have x squared times x squared over y divided by y squared. We'll simplify that a little bit. I'll have x to the 4th here, so I'll get 2xy minus x to the 4th over y divided by y squared. And the last thing I do is just divide everything by y squared, and you get your final answer that doesn't look too bad, is 2x over y minus x to the 4th over y cubed. And that's the second derivative of y with respect to x. So there's the first example. Again, the process is find the first derivative, then the second derivative, then substitute back in for dy dx. Let's look at example number 2 now. So for example number 2, we are going to take, paper's organized here, sorry. We are going to take y squared equals x squared plus 2x. And we're going to find the second derivative. So same instructions. You should try this one on your own. See how, then pause the video, try it, and then see how it goes, and then check your answer. So we'll take the derivative here. Hopefully you paused and gave it a try. So this will be 2y dy dx. It's implicitly defined, and on the right I'll get 2x plus 2. Divide both sides by 2y, and you get dy dx is equal to 2x plus 2 over 2y. Clean this up a little bit. If I take a 2 out in front of the numerator, we're left with this, 2 times x plus 1 divided by 2y, and 2 over 2 is just simplifies to 1 over 1. So I get, finally, dy dx is equal to x plus 1 over y. Okay? Now, let's go over here and find the second derivative. So the second derivative of y with respect to x is going to be to take the derivative of this. Again, a quotient, not the greatest thing ever, but I'll take the bottom times the derivative of the top, which is just 1, minus the top, x plus 1, times the derivative of the bottom. And the derivative of the bottom is just dy dx, divided by the bottom squared. Okay, now I'm going to clean this up, and I'm going to plug in for dy dx. I'm going to take this expression here, x plus 1y, and plug that in because I want my final answer to be in terms of x and y. So I will get y minus x plus 1 times x plus 1 over y, all divided by y squared. Keep on going. We're going to clean this up. So we've got y minus, this will be x plus 1 times x plus 1. That's x plus 1 squared, all divided by y. That's all divided by y squared. Now, I can do a common denominator on the top, but I'm going to do this a little bit differently. To clean it up, I'm going to use a technique which I informally call clearing out the fractions. So I'm going to multiply the top and the bottom by y, which is my denominator here. And that's the same as multiplying by 1, but watch what happens. I end up with this, y squared minus, and then, so if I'm saying y times y, which is y squared, and then y times this will just be y over y, so I'll just get x plus 1 squared divided by the bottom, which is y cubed. Now, this is a fine answer, but I'm going to show you what happens when I multiply this entire thing out on top and then simplify, because it's sort of, if you're mathematically nerdy, it's sort of a cool thing that happens. So again, if you ended here on a test or a quiz, that's fine. But watch what happens when we expand this whole thing out. I get y squared minus, and this will be x squared plus 2x plus 1 divided by y cubed. Okay, now y squared is the same as x squared plus 2x. So what I can do is I can take x squared plus 2x and plug that in for y squared here. Why would I do that? Because I have an x squared plus 2x here, and I'm subtracting it. So I might get a bunch of stuff to simplify to 0. So let's check and see if that works. So I'll get x squared plus 2x minus x squared minus 2x minus 1, and you can see that, yeah, x squared minus x squared is 0, 2x minus 2x is 0. I got a negative 1 still on top, all divided by y cubed. So my final answer for dy, the second derivative of y with respect to x, is going to be negative 1 divided by y cubed. Now, isn't that so much nicer than this expression here, right here? I just think that turns out to look a lot better in the end. So that's it for part 2 and second derivatives. It's a lot of algebra, being very careful with the way that you simplify things, being careful with common denominators and negatives, but otherwise the concept on its own I don't think is really too bad. So that's and that wraps up all of implicit differentiation.